Hello everyone, welcome to Cypher Page, and today we are going to solve Leetcode number 3310, that is remove methods from project. In this question we are given uh, you are given maintaining a project that has n methods numbered from 0 to n minus 1. Okay, you are given two integers n and k and a 2D integer array invocations where invocations of I is a list of A and B indicates that method A invokes method B. Okay, so it is a kind of graph question. Here, there is a known bug, that is method K. From 0 to n minus 1, actually these are the nodes in this question, and you are given a value K, that is the kth node is a what is considered as a suspicious node. So what we have to do in this question, we have to remove all those nodes that are connected to K or that are either directly or indirectly considered as suspicious. Okay, so all those we have to remove all those nodes from the our resultant array which have any methods that are invoked directly or indirectly by kth node. Okay, so a group of methods can also be removed if no method outside the group invokes any methods within it. Okay, suppose there is in this question, in this example, we can see that our n is equals to 4. That means in this graph we can see there are 4 nodes and these are the invocations. Okay, so I'm just building it here right now. Suppose these are our 4 nodes. Okay, and you can see here the invocation is, the first element is A, second element is B, and A invokes B. That means from A, it is a directed graph, you can say. From A, we are pointing to B, that is 2, from 1 to 2. Similarly, from 0 to 1, there is a dependency, and then 3 to 2, that means 3 is invoking 2. Okay, so this is the graph that we'll make, and here you can see our suspicious node is 1. So 1 is considered as suspicious node. So I'm rounding it now, and we have to remove, what we have to do, we have to remove all those nodes which are directly or indirectly invoked by kth node, that is 2 in this case. Okay, that is 1 in this case. Okay, so from 1 we can say here you can say that 2 node 2 is invoked by 1, so we have to remove these 2 nodes. But also in this question it is given that a group of methods can only be removed if no method outside a group invokes any method within its range. Okay, so that means if kth node, if any member of the kth node, we can say these are the group of nodes, if any method of the kth node is invoked by non-suspicious nodes. What I mean to say is that if any node that is not suspicious points to a suspicious node, then we will not remove any node. Okay, and so in this question we can see that this node 2, node 0 and node 3 is invoking these 1 and 2 are the suspicious node. So these two are invoking these suspicious nodes. So in this case we will not remove any node from our resultant answer, so we will return all these nodes in our answer. Okay, So this will be our answer. In the next question, we can say, this is, in the next example, we can say that is here n is equals to 5. So we will make 5 nodes, 0, 1, 2, 3, 4. Okay, these are the 5 nodes. And 1 points to 2. So 1 is pointing to 2. 0 is pointing to 2. So I'm making it like that. And then 0 is pointing to 1. And 3 is pointing to 4. Okay, so this is our basic graph for this example. And here you can see that there are 2 components within the graph. Okay, this is the first component and this is the second component. Okay, now here the suspicious node, that is kth node, is 0. So we have to remove all those nodes that are directly or indirectly depending on this nodes. So in this case 0 is pointing to 1, so 1 is also a suspicious node, and 1 is pointing to 2. 2 is also a suspicious node. So these all three, this group of suspicious node is should be removed. And here we can say not a single non-suspicious node is pointing towards them. Suppose if 3 is pointing to 0, in that case we will not remove any of the node. But in this case we can see the group of nodes is like this whole should be removed. So what we will return in our answer, we will return all the non-suspicious nodes that are 3 and 4. So the answer will be 3 and 4. And in the third example we can see that there are n is equals to 3. So 1, 2, 3. We have made 3 nodes, and here 2 is the suspicious node and 1 is pointing to 2. 0 is pointing to 1 and 2 is pointing to 0. Okay, so in this case suspicious node is 2. So what we will do, we will just remove all these dependent or dependents directly or indirectly nodes that are a part of this K. So we have to remove all these nodes and our resultant will be null. So we will return a empty array, empty vector in this case. Okay, so how we will solve this question? Let's come to that part. Okay, here we can say that we have to first, like we are given invocations. Can we convert it into a graph question? Of course, definitely. So what we will do is that first, these are like edges given to a normal graph question. So what we can do, we can make a adjacency list from this. So this will be our step 1. Now we need to find out the nodes that are directly or indirectly connected by kth node. So we have to apply DFS traversal to find directly connected nodes, directly or indirectly connected nodes to kth node. Okay, and later we have to return if any single, even a single non-suspicious node point to suspicious node, then we will return all the nodes, because in that case we will not then we will return all the nodes, because in that case we will not remove any node. And if otherwise, okay, otherwise we will return all the remaining non-suspicious nodes. Okay, so I hope you got what we will do. First, what we need to do, we will make the adjacency list. Okay, and then we will call a DFS traversal, and If any single node is there, any single non-suspicious node is pointing to a suspicious node, then we will return all the nodes. Otherwise, we will return only the remaining non-suspicious nodes. I hope you got how we will do it. So let's try to implement in Leetcode. Okay, so what I'm just trying to do, first I'm just making like n is already passed. First I need to make a adjacency list. So I'm just making vector of list int, and that will be our adjacency list adj of size n, I guess, because there are n nodes. Now what I will do, I'll just traverse over this vector of vector ints auto edges, we can say e, and in this invocations, and what we'll do is this e. Okay, instead of e, what should I do? Okay, I'm just writing directly as, I just forgot the syntax. Okay, will it work like that or not? Auto e. What I'll do is that e of 0, okay, I have to push back in this adjacency list adj list of this e of 0 dot pushback e of 1. Okay, so this is how we will push back. You can assume it as a, and you can assume it this e1 as b. Okay, so this is how you will create the adjacency list. Later what we need to do is we need to use our DFS function. So I'm just making a DFS function, void DFS function, and we have to also make a vector bool to mark the visited nodes. So I'm just making a visited vector with all values initialized as false, and then I will call a DFS function where I will send this adjacency list and the k node, and what else, and the visited vector. Okay, so I'm just making a DFS function. I will have this vector of list of int adjacency list. I should write ampersand as well, and I will pass this k, and I will pass this vector whether the node is visited or not. So for that I'm passing this vector visited. Okay, instead of k I'm just writing u. Okay, now what I will mark is how we will just write this function. If we will first mark node u as true, that means it is visited. Thereafter we will iterate over this list and int of v, the adjacent neighbors of this u node. So adjacency list of u, and if this adjacent nodes are not visited, then we will call this DFS function again, adjacency list. We will send this node v, and again this visited. Okay, I need to mark this ampersand because we don't make to another copy again. So this is how we will write the DFS function. Now later we will iterate over this for int I equals to 0, I less than okay, instead of this what I will do, okay, I equals to 0, I less than this invocations dot size I plus plus if okay, let's say int a equals to instead of this, what I can do is I can use this now, auto e invocations if visited. Okay, I'm writing int a equals to e of 0, that is, and int b equals to e of 1. Okay, if visited a, if a is not visited, that means it is not a suspicious node, and b is visited, that means it is a suspicious node. Here a is not a non-suspicious and b is suspicious. In that case, what we will do, we will return all the uh, nodes. So first of all, I need to make a int answer array. Okay, and in that case, what I'll do, I will just return all the nodes. So I'm just writing int I equals to 0, I less than n, I less than n, I plus plus ans dot pushback I. Okay, this is how we will return all the nodes. Otherwise what we'll do, we will return all the non-visited nodes. For that, I will iterate over this visited array. So what I'm just doing, for bool let's say f visited, okay, if, okay, I should write bool here also, if not visited, then we will push back in our resultant vector ans dot pushback f. Okay, and in that case we will return our ans. Okay, and yeah, we have to, if this if condition is true, here we have to return our answer as well. Okay, let's submit this question. Okay, so there is a if condition. Okay, if adjacency, if not visited now. Okay,